Good morning, students. To find the rank of a matrix using minor method, we have two methods to find rank of a matrix. The first method is minor method. The second one is row reduction method. This row reduction method is given in the second sum. The first sum is nothing but we have nearly 5 solutions, I think so. In these 5 solutions, we are going to study the minor method. So, minor method is nothing but finding the determinant value. Listen very carefully. Finding the determinant value is nothing but the minor method. That's all. Finding the determinant value. Mostly, if 2 cross 2 is given, no problem. This is no problem. But this has some problem. This also has problem. I will say what is the problem. Before that, for all the things we need to know the order of a matrix. What is the order for this matrix? Order of a matrix nothing. How many rows? 2 rows, 2 columns. What is order for this matrix? 1, 2, 3. 3 rows, 2 columns. 1, 2. What is order for this matrix? 1, 2 rows and 4 columns. 2 rows, 1, 2, 2 rows, 4 columns. This is the first subdivision, second subdivision, third subdivision. This is taken as one of the example to explain the sums. I'm not the sum which I'm going to do now is not a correct one, but I'm going to explain with these sums. After that, I will proceed the sum very carefully. So, minor method, row of A, this row of A, row of A, this row of A is being indicated for rank of the matrix, rank of a matrix. How this is row of A. This row of A is indicated for rank of a matrix. We don't need to write rank of a matrix is equal to. In spite of writing rank of a matrix, we can write row of A. This is row of A. This row of A we studied in 11th also. This symbol row of A. So row of A is nothing but rank of a matrix. So before finding row of A, we have formula for minor method. That is row of A is less than equal to minimum of the same row of A. If I am going to take this matrix as A, if I am going to take this matrix B, name it as B. Row of B is less than equal to minimum of the same. If I am going to take this matrix as C, row of C is less than or equal to minimum of. So this is the formula. What is minimum of? What is the minimum of? Minimum of order 2 rows, 2 columns. Here 2 rows, 2 columns. Here 3 rows and 2 columns. 3 rows, 2 columns. Here 2 rows, 4 columns. If you are going to see which one is minimum here, 2, both are 2. In both are 2, so less than or equal to we can write, no problem. Therefore, rank of a matrix will be less than or equal to. What is less than or equal to? It can be 2, it can be 1. It cannot be 0, 2 and 1 only. Mostly the rank of a matrix is nothing but natural numbers. It cannot be 0. So in 2, this row is also 2, column is also 2. If we are going to say 2, 2, in this which one is minimum? 2, 2, which one is minimum? 2, both are same 2. So write 2, less than or equal to. So less than or equal to minimum of 3, 2. 3 is minimum or 2 is minimum? 2 is minimum. So less than or equal to, for this matrix, the rank can be 2 or 1. It can be 2 or 1. That's all. This one is the idea, basic idea. For less than or equal to minimum of 2, 4. 2 is minimum or 4 is minimum? 2 is minimum. So this is 2. This is the main thing we need to know in minor method. In minor method, this is the main thing you need to know. First you need to find the order. Order of a matrix is 2 cross 2. This is 3 cross 2, 2 cross 4. Next the formula. Row of A is less than equal to minimum of row in comma column. Row of B is less than equal to minimum of row comma column. Row of C is less than or equal to minimum of row comma column. In which one is minimum? Right. Both are same. So 2. 2 is minimum. Right. 2. 2 is minimum. Right. 2. 2 means it can be 1 or 2. 1 or 2. It can be 1 and 2. The rank of a matrix either it can be 1 or 2. 1 or 2. 1 or 2. It can be 1 or 2. For example, find this determinant value. Determinant of A is equal to determinant of 2 minus 4 minus 1 2 is equal to, always put minus. This one I teach you in 11th standard. Always put minus. 2 2s are 4. Minus into minus plus. 1 into 4 is 4. Answer is 0. If one's answer is 0, row of A cannot be 2. So this one only the method I am going to teach you. Understand very carefully. Suppose this has some constant. For example, 5. This has constant called 5. Suppose now it is 4. Suppose answer is now it is 0. Suppose answer is 5. You can stop. You can write row of A is equal to 2. You can stop and write row of A is equal to 2. Suppose 0. 0 means row of A cannot be 2. If row of A cannot be 2, the row of A should be 1. So 0 means you will move to another rank. If once it comes 0, in 2 cross 2 it comes, once it comes 0, next I need to move to another rank, that is 1. So row of A is equal to 1. Suppose it is not equal to 0. For example, minus 1, we get minus 1. You will write row of A is equal to 2. That's a rank it will 2. If it is 1, I can write row of A equal to 2. If it is minus 1, I can write row of A is equal to 2. If it is minus 5, I can write row of A equal to 2. If it is 0, I need to write row of A is equal to 1. Now I think you can understand. 0, if 0 comes, I need to move to another rank. If 0 comes, so 2 means it can be 1 or 2, that's all. Rank can be 1 or 2. As 0 comes, the rank cannot be 2, so rank will be 1, that's all. How easily finished the sum. Next we move. All are 2 cross 2, so no problem. So B is equal to, in this I can divide this matrix into 3 ways. In this matrix we can divide in 3 ways. In these 3 ways we need to check. What is the 3 ways? First minor. What is the minus 1, 3, 4, minus 7. Minus 1, 3, 4, minus 7. Next minor. Next 2 cross 2 minor. 4, minus 7, 3, minus 4. 4, minus 7, 3, minus 4. Next minor. What will be? Minus 1, 3, minus 1, 3, 3, minus 4. So we have 3, 2 cross 2 minus. What is the first minor? This is one minor. This is another minor. This both is another minor. We need to check all the 3 minors. Listen carefully. If all the 3 minors are 0, then row of A equal to 1. Listen very, very carefully. If all the 3 minors are 0, this one is 0. Suppose 0, I am not done, but I am telling 0, 0, 0, it cannot be 2, it can be 1. Suppose 0, 0, 1. If any 1 contains a value, in this 3, 2 cross 2 minor, in this 3, 2 cross 2 minor, if any 1 contain value, for example, this one is minus 2, 0, 0, 5, 0, 0, 6, if you contain this value, contain 6, otherwise 6, 0, 0, any 1 contain value also, row of A is equal to 2. When row of A is equal to 1, all these 3, 2 cross 2, all these 3, 1, 2, 3, all these 3, 2 cross 2 minus is 0, then I can write row of A equal to 1. If any one contain one value, that is 1, 2, 3, minus 1, minus any one, for example, this is minus 1, 0, 0, you can say, you can openly say the answer row of A equal to 2. You can understand, I think so. So we check the answer, always minus. Minus into minus plus, 1 into 7 is 7. 4 3s are 12, which is not equal to 0. Simply you can write row of A equal to 2. I don't need to check this one. I don't know. Any one is not 0. Any one is not 0. That's enough. Suppose this both are going to 0, no problem. Like I put minus. Minus into minus plus, 1 into 4. Nothing going to be. Nothing going to be. Any one is not equal to 0. Any one is not equal to 0. Then you can write row of A is equal to 2. No problem. You don't need to check this one also. Simply write row of equal to 2. That's all. If suppose this one also 0, this one also 0, this one 0, the row of A cannot be 2, row of A should be 1. That's all. Row of A should be 1. But fortunately, 1 is not equal to 0. Fortunately, not equal to 0. We can write row of A is equal to 2. Check this one. So this one how I can check? Easy method. Take any one determinant. I don't need to check. I don't need to use 3 determinants. Take any one determinant. This 2 no. It can be 2 or 1. I need to show any 1 is not equal to 0. Take any 1 2 cross 2 determinant. Show any 1 is not equal to 0. Then row of equal to 2. So I am going to choose this one. Take this one. Minus 1 0. And use determinant. So determinant minus 1 0 minus 3 1. Easily you can say it is not equal to 0. Put minus 1. This is 0, which is minus 1, which is not equal to 0. Therefore row of A is equal to 2. So suppose if I go to take this one, sir, take it, see, determinant 1, 2, 3, minus 6. What is the answer? Always put minus. 1 into minus 6, minus 6. 3 2s are 6. 1 into minus 6 is minus 6. Always put minus. 3 2s are 6. So minus 6, the answer doesn't come. This is also not equal to 0. If anyone, if you go and take this one, this is also not equal. Suppose it can be 0, no problem. We don't need. The main thing in minor method, if this not equal to 0, you can choose row of equal to. Can anyone understand? I think so. Not equal to row of equal to. Suppose this is also 0. I want to another. I want to choose another determinant. This one. I need to choose this one. So I want to move one by one. So take one determinant value which is not equal to 0. I can close the answer. So using this one we need to find. Now I am going to explain the sum. So first sum, find the rank of a matrix using minor method. Given and choose let A is equal to. Therefore first write a formula. Row of A is less than equal to minimum of m row, number of rows 2 rows, number of columns 3, less than or equal to 2. Therefore rank can be 2. Therefore it can be 2 or 1. So I am going to take determinant value. This is a first determinant value 2 minus 4 minus 1 2, which is always minus. 2 2s are 4, minus into minus plus 1 into 4 is 4, which is equal to 0. Since it is 0, row of A cannot be 2. Therefore row of A is equal to 1. We can stop the matrix here itself. Next I will choose second subdivision. Second subdivision is minus 1 3, minus 1 3, 4 minus 7, 3 minus 4. Solution. Listen very carefully, students. Let I will choose always A only. Let A is equal to minus 1 3, 4 minus 7, 3 minus 4. So row of A is less than equal to minimum of how many rows? 3 rows. How many column? 2 column. 3 comma 2. This one I have done. In which one is minimum? 2 is minimum. So write 2. It can be 2 or 1. We can stop. How many determinant we can form? 1. This is how many one? This is 1. This is 2. This one. 3 determinant we can form. But I am going to choose only one determinant which is not equal to 0. So once if I am going to show not equal to 0, not equal to 0 means row of A equal to 2. If equal to 0, row of A equal to 1. I want to show any 1 is not equal to 0. Suppose all the 3 are going to 0, there is no way. I need to put all the 3, I need to put row of A equal to 1. If any 1 is not equal to 0, I don't need to put another 2, no. So I want to choose any 1. So I am going to take the first one itself, no problem. What is first one? Minus 1, 3. Minus 1, 3. 4 minus 7. Always put minus. Minus into minus plus 1 into 7 is 7. 4 3s are 12, which is minus 5, which is not equal to 0. Therefore, row of A is equal to 2. Easily we can finish. If it is 0, only problem. Suppose if I am going to take this determinant and going to be 0, I want to take another determinant. If that also 0, I want to take another determinant. So that also 0, row of A is equal to 1. If these 3 determinants, any 1 is not equal to 0, that enough. I can put row of A equal to 2. So any 1 is not equal to 0, yes, row of A is equal to 2. Now we move towards the third subdivision. So third subdivision, I will take A is equal, let A is equal to 1, minus 2, minus 1, 0, 3, minus 6, minus 3 and 1. So I am going to take row of A. Row of A is less than equal to minimum of how many rows? 2 rows. How many columns? 4 columns. 2 comma 4. 2 rows, 4 columns. In that, which one is minimum? 2 is minimum, less than equal to 2. Therefore, the rank can be 1 or 2. I want to choose any one determinant. I want to choose only one determinant which is not equal to 0. I want to choose only one determinant which is not equal to 0. Choose any one. This is C, minus 6. Suppose if I go to 6, I contain some problem. It will be some problem. I am not going to choose this one. So choose this one, sir. See, if I am going to choose this one, 1 minus 2, 3 minus 6. Always put minus. 1 into minus 6 minus 6. 3 into minus 6 minus 6. Already minus, so put plus 6 which is equal to 0. Once equal to 0, I should not write row of equal to 1. I want to choose another determinant. In spite of doing equal to 0, I am going to choose this determinant alone, which is not equal to 0. Choose any one determinant which is not equal to 0. So I can write minus 1 0, minus 3 1 is equal to put always minus, minus 1 into minus 1, minus 3 into 0 0. So minus 1 which is not equal to 0. So we have got not equal to 0. We can close our ranks and write row of A is equal to 2. We can stop our answer and write row of A is equal to 2. Next, the fourth subdivision. In this fourth subdivision, they are given the matrix 3 cross 3 determinant. 1 minus 2 3, 2 4 minus 6, 5 1 minus 1. They given 3 cross 3. We don't need to fear for that. Solution, let A is equal to, first write, let A is equal to matrix 1 minus 2 3, 2 4 minus 6, 5 1 minus 1, 5 1 minus 1. So now row of A is equal to less than equal to minimum of 3 comma 3. 3 rows 3 column less than equal to 3. Both are 3 no. So which one is less? I can't say. The 3 is the common one. So how the rank will be 1, 2, 3. The rank can be 3. If this one is, for first this take this determinant alone, 1 minus 2 3, 2 4 minus 6, 5 1 minus 1. Listen students, if this determinant is not equal to 0, rank will be 3. If this determinant is equal to 0, rank will be 2 or 1. You can able to understand, I think so. Listen carefully. If this determinant is equal to 0, rank cannot be 3. It can be 2 or 1. If this determinant is not equal to 0, then rank will be 3. We can finish it itself. So we'll move. So you know, this is plus, this is minus, this is plus. So plus 1, open the bracket, minus. Minus into minus, plus 2, open the bracket, minus. Plus 3, open the bracket, minus. So 1. 4 into minus 1 is minus 4. 1 into minus 1 is minus 6. Already minus, so write plus 6. 2 into minus 1 is minus 2. 5 into minus 6 minus 6. Already minus, so put plus 30. 5 into minus 6 plus 30. 3. 2 into 1 is 2. 5 4s are 20. So what is the answer? 1. Minus 4 plus 6 is 2. 2. This is going to be 28. 30 minus 2. 3. This is minus 18. 2 minus 20 minus 2 plus 8 2s are 16. Carry 1. 2 2s are 4. 4 plus 1 5. 56. Minus 8 3 24. 4 carry over 2. 3. 3 into 1 3. 3 plus 1 4. Surely if we are going to say this is 58, this is minus 44. I will check once again. 1 into 2 is 2. 8 2s are 16. Carry 1 to 4 5. 4 carry 2. This is 54 students. Sorry, this is 54. What is the answer? 4, which is not equal to 0. 8 3 24, which is not equal to 0. Which is not equal to 0. So we can stop our answer, right? Row of A is equal to 3. Suppose, this is about, suppose is equal to 0. Then you can't say row of A equal to 3. It can be 2 or 1. For 2, I want to choose 2 cross 2. This is 1 2 cross 2. This is another 2 cross 2. This is another 2 cross 2. This one. That is a 4 2 cross 4 2 cross 2 minor. In this 4, any 1 is not equal to 0. Any 1 in this 4 determinant, any 1 is not equal to 0, row of A equal to 2. If 4 are not equal to 0, row of A is equal to 1. This is the main idea and concept you need to learn. This one I need to teach you. So next, fifth subdivision. So this is given 3 cross 4. Let A equal to choose 0 1 2 1 0 2 4 3 8 1 0 2. First side formula, row of A is less than equal to minimum of how many rows? 3 rows. How many column? 4 column. Less than equal to minimum is 3. That's all. Minimum is 3. No. 3 comma 4. Which one is the minimum? 3. That's all. It can be 3 2 1. But problem is this is not 3 cross 3. I need to choose 3 cross 3. I need to choose 3 cross 3. But what 3 cross 3 I am going to use? First I will do this 3 cross 3. How? See, 0 1 2 0 1 2 0 2 4 8 1 0. I will expand in column wise. Plus minus plus. So plus 8 alone, plus 8 alone. Open the bracket, minus. This 0 no, nothing. 0 nothing. 8 alone. 1 into 4 is 4. 2 2s are 4. Going to see answer got 0. 4 minus 4 is 0. 0 into 8 is 0. So row of A is not 2, sir. We need to go. No. This is 1 3 cross 3. I need to choose another 3 cross 3. This will be another 3 cross 3. I want to move like that. Totally it has nearly 1, 2, 3, 1, 3 cross 3, 1, 2, 3, another 3 cross 3, 1, 2, 3 and 1, 2, 3. There is many 3. I will write how many 3 cross 3. Listen, first after finishing the sum I will write. Next I choose this one. 1, 2, 1. 1, 2, 1, 2, 4, 3, 1, 0, 2. So this will be plus, minus and plus. So 1 open the bracket minus, minus 2 open the bracket minus, plus 1 open the bracket minus. 4 2s are 8, 0 into 3 0, 2 2s are 4, 1 into 3 3, 2 into 0 0, 1 into 4 4, 8 minus 0 8, 8 into 1 8, 4 minus 3 1, 1 into minus 2 minus 2. This is minus 4, 1 into minus 4 minus 4. So what's the answer going to be? Listen very carefully. I have taken 1 2 1, 2 4 3, 1 0 2. For this one, 4 2s are 8, 0 into 3 0, 2 2s are 4, 1 into 3 is 3. This one 2 into 0 0, 1 into 4 4. So 8 minus 0 is 8, 8 into 1 is 8. 4 minus 3 is 1, 1 into minus 2 is minus 2. 0 minus 4 is minus 4, 1 into minus 4 is I written minus 4. This become 8 minus 6, which is 2, which is not equal to 0. Now you can write row of A is equal to 3. That is many 3 cross 3. How many 3 cross 3 I will write? The first 3 cross will be this one, 8, this one. Right? 0, 1, 2, 0, 2, 4, 8, 1, 0. This is first 3 cross 3. Another 3 cross 3, 1, 2, 1, this one. 1, 2, 1, 2, 4, 3, 1, 0, 2. Another 3 cross 3. This one, and not this one, this one, this one, this one. Or 0, 1, 1, 0, 2, 3, 8, 1, 2. This one. 1, 2, this one. That is another 3 cross 3? Yes, that is another 3 cross 3. This one, and this one. 0, 0, 8, 2, 4, 0, 1, 3, 2. See how many determinants we have found? There is any determinant. If you are going to check, that's all. There is no determinant. Easy. This is the 1A. There are 4 determinants. In this one is equal to 0. This one is not equal to 0. Therefore, row of A 3. Suppose, not 0. Suppose this one is 0. This one is 0. This one is 0. This one is 0. Row of A cannot be 3. Row of A can be 2 or 1. 2 or 1. For 2, I need to check 2 cross determinant. How can I check 2 cross 2? First this one, this determinant. 0, 1, 0, 2, 1. This first one. Next, this one. 1, 2, 2, 4. Next, this one. 2, 1, 4, 3. Next, 0, 2, 8, 1. 0, 2, 8, 1. Next, after 0, 2, 8, 1. 2, 4, 1, 0. 2, 4, 1, 0. 2, 4, 1, 0. Next, 4, 3, 0, 2. See how much is present? 1, 2, 3, 4, 5, 6. 6 is present. Suppose this 0, this one 0, this one 0, this one 0. This one 0, 0, 0, 0, 0, 0. Row of A is not 3, row of A is not 2, and surely row of A is 1. Suppose this one 0, 0, 0, 0. In any one, this 2 cross 2 determine any one is not equal to 0, row of A equal to 2. If all are 0, row of A equal to 1. So I think I made you to understand that how to derive this minor method. Thank you. Good morning, students. Next, rank of a matrix finding using row reduction method. This method is very, very important for higher standard. Using this method only we can able to solve the exercise 1.5 Gaussian elimination method. Without knowing this method, we can't solve Gaussian elimination method. So students, please try to understand. These are the steps not given in our textbook. These are steps created by myself. These are the rules created by myself to make this solve, to solve this sum very easily. So only step 1, step 2, step 3, step 4, and step 5 is the formula. Rank of a matrix row of A is equal to number of non-zero rows. I will explain what is my 0 rows and what is my non-zero rows. I will explain finally. Now I have taken one general matrix A11, A12, A13, This one indicates rows, this one indicates one. First row, if I go in, this one is R1 row, R2 row, R3 row, column 1, column 2, column 3. The first one indicates first row, first column. A32, third row, second column. This is third row, this second column. Third row, second column. A31, 3 indicates row, 1 indicates third row, first column. Third row, first column. These are the matrix. So first step 1. Please students, please memorize these steps. Otherwise you can't able to do the sum. Once you have memorized, then you don't need to forget. You don't forget, because doing the sums continuously you can get an idea what you want to do. So only 10 steps. What is step number 1? A11. This is A11. This A11 can be 1 or minus 1. It can be 1. Why the A1 should be 1? To solve this sum, if it is going to be 1, this place, not this place, for example, if this place is going to be 1, then I can easily solve the sum. It can be place, can be 1 or minus 1. The first place, the first element can be 1 or minus 1. If it is going to be 1 or minus 1, then I can easily able to solve this sum. So only the first place should be 1 or minus 1. Then I can easily able to solve this one very easily. So you understand, I think so. Step 2, make A21, A31. This place and this place, I need to make 0. This place, for this place and this place should be 0. For making these two places, I need to get the help of R1. Why? This one I am going to change, this one I am going to change. Since I am going to change this A21 present the R2, listen carefully. Since this A21 is present in the R2, there is a change. Since A31 is present in the R3, the whole row can be changed. This whole row going to be changed. This whole row going to be changed. There is no change in R1. So only I am getting the help of R1. Not only I am getting the help of R1. So only in step 1, I am making this first element as 1. If the first element is 1 or minus 1, these two elements I can make easily as 0. I think you can easily understand somewhat. If a first element is going to be 1 or minus 1, then I can easily able to make these two elements as 0 with the help of R1. It moves with the help of R1, with the help of moves R1. Because R2, this A21, this A31. This A21 is in R2, this A31 is in R3. That is change in the whole row. There is no change in R1. So when I am getting the help of R1, I am getting the help of R1 with the help of R1. This. So next. Make A32. Which one is A32? This is A32. Make A32 0 with the help of R2. I need to make this one as 0. But for making this one as 0, I am getting the help of, that is A3, this A32. There is change in R3. Why? A32 is present in R3. A32 is present in R3. There is change in R3. There is no change in R2 and R1. So in order to make this A3 0, I am getting the help of R2. Sir, can you get the help of R1, sir? No, you should not move to R1. If I want to make this one as 0, I need to get the help of R2 alone. Don't move to R1. If you are going to move R1, this 1 comes once again here. While doing the sums, you can understand. This 1 comes once again here. Always should be 0, no. If I am going to move to R1, this 1 comes here. If I am going to move this one, no problem. This is the main thing. Next step. So this one is 0, this one is 0, this one is 0, get help of R2. Next step. Number of zeros in a row should be greater than the previous row. This one is the main thing. See, if we are going to this one 0. This one can be 2, 3, 4, 5, 6. So what is the meaning? 1, 2, 3, 0, 4, 5, 0, 0, 6. In R3, how many 0 is present? In R3, how many 0 is present? 2 zeros, 1 and 2. In R2, how many 0 is present? Only 1 0. So which one is greater? The last row 0, the last row. The number of zeros in the last row. I left one word, last row. The number of zeros in the last row should be greater than the previous row. Yes, it contains 2 zeros. It contains only 1 0. Yes, the last row contains many zeros. The last row contains 2 zeros. Its previous row contains only 1 zeros. So which one is greater? This one is. The step 4 also satisfies. Nothing but listen carefully. 1, 2, 3, 0, 4, 5, 0, 0, 6. How many zeros? It contains 2 zeros. How many zeros? It contains only 1 zero. This is greater when compared to this one. It contains 2 zeros. It contains only 1 zero. This one, number of zeros in the last row. The number of zeros in the last row should be greater. Yes, greater only than the previous row. Yes. So I'm going to teach you what is my zero row, what is my non-zero row. For example, see this is 1, 2, 3, 0, 0, 0, 0, 0 and 1. 1, 2, 3, 0, 0, 0, 0, 0, 0, 1, 2, 3, 0, 0, 1, 0, 0, 2. What is meant by non-zero rows? This is non-zero rows and zero rows. Non-zero rows, zero rows. What is non-zero rows and zero rows? Non-zero rows and zero rows. I am going to check. What is meant by non-zero rows? Non-zero row is nothing but, first I will check the zero row. Zero row means fully zero is nothing but zero row. But see, 0, 0, 1. One element is present. It is non-zero. This is zero row. This is non-zero, non-zero. Because one element is present. So non-zero is 2. Zero row is 1. What is my non-zero? Non-zero is nothing. What is? I will say 0. Zero means the full row contains only zeros. Zero row means the full row contains only zeros. It is called zero rows. Yes, only zero rows. Non-zero 1 2. You can see how many zero rows? 1, 2. 1 non-zero, 1. See here. How many zero rows? It contains 2. It contains 1. 0, 0 rows. 3 non-zero rows. You can able to understand this row because zero row is fully zero. The row contains fully zero. Row contains fully zero. Row contains no zero. Contains 2 zeros. But problem is this one. So what is the formula? Step 5. Rank of a matrix. Row of innocent. Number of non-zero rows. What is the rank for this matrix? 2. Non-zero. Number of non-zero rows. Row for this matrix 2. Rank is nothing but 1. Rank is nothing but 3. Because the rank is number of non-zero rows. Non-zero rows. This is the rank. Number of non-zero rows. This is the rank. The main thing. This one is problem is nothing but 0, 0, 0, 0. The step 4 does not satisfy here. 0, 0, 0. Number of zeros in the last row should be greater than the previous row. Here also 2 zeros, here also not satisfies. For during such condition, I need to make this one as 0. I will teach you while getting the class. Teach you. I think I have somewhat strained to take these rules. While doing the sum only, you have plenty of questions you need to ask me. If any question you can ask me, then I will ready to teach. Find the rank of a matrix using row reduction method. Find the rank of a matrix using row reduction method. Solution. First name the matrix. Solution. First name the matrix. Let A is equal to 1, 1, 1, 3, 2, minus 1, 3, 4, 5, minus 1, 7, 11. This is matrix. We have named the matrix. Next, first step, A11 can be 1 or minus 1. A1 or minus 1. The first step satisfies. Second step, A21 should be 0. A31, this both should be 0. While this both should be 0, I need to get help of R1. I need to get help of R1. It's similar. So, since I am going to get the help of R1, there is no change in R1, there is change in R2 and R3. So, write R1 as this 1, 1, 1, 3. There is change in R2, there is change in R3. So, write R2 going to change and R3 going to change. How R2 and R3 I am going to change? See here, this is 2, this is 1. If you want to come, this one is 0. I need to get a 2. I need to multiply this one with the element minus 2. This is 1. 1 is multiplied minus 2. 1 into minus 2 is minus 2. Minus 2 plus 2 becomes 0. I need to multiply this whole R1 as 0. See here, R2 tends to write R2 as minus. If this is 2, this one want to be this one, this should not be 1. This one should be minus 2. 2 minus 2, 0. In order to become this one as minus 2, I need to multiply with minus 2. 1 should be multiplied with minus 2. R2 minus 2 R1. Now check it. Write R2 now. Write R2 here. But 2 minus 1, 3, 4. 2 minus 1, 3, 4. Next, R1 should be multiplied with minus 2. 1 into minus 2, minus 2. 1 into minus 2, minus 2. 1 into minus 2, minus 2. 3 into minus 2, minus 6. 2 minus 2, 0. Minus 1 minus 2, minus 3. 3 minus 2, 1. 4 minus 2, minus 2. 0, minus 3, 1 and minus 2 over. So we have got 0. Now this is 5. What this one should be? This one should be minus 5. Minus 5 plus 5, 0. So I need to multiply with minus 5. R3 tends to write R3 minus 5 R1. Write R3 first. 5 minus 1, 7, 11. 5 minus 1, 7, 11. R1 should be multiplied with minus 5. 1 into minus 5, minus 5. 1 into minus 5, minus 5. 1 into minus 5, minus 5. 3 into minus 5 is minus 15. Check the answer. 5 minus 5, 0. This will become minus 6. 7 minus 5, 2. 11 minus 15 is minus 4. What is the answer? 0, 6, minus 6, 2 and minus 4. So how I can do this sum? Now this one becomes 0. But before doing that, minus 6, 2, minus 4. All are divisible by 2. So divisible by 2. Then the sum will be very easy. Divisible by 2. That is, this one alone I am going to do. This one no change. There is no change in R1, R2. Right? R1, R2 as it is 1, 1, 1, 3. 0, minus 3, 1, minus 2. Therefore, R3 tends to R3 divided by minus 2. Why minus 2? I will teach you. Minus 2 is better. To do minus 2, 0. Minus, minus, cancel. 6 divided by 2, 3. 2. 2 cancel, but remaining minus 1. Minus, minus cancel. 4 divided by 2 is 2. Now check which one is 0. A21, A31 is 0. Rule 3. A32 should be 0. A32, which is A32? 0. If I want to get A32 should be 0, I need to get the help of R2 alone. This is R2. 3 minus 3, 0. Sir, I want to make this element is 0. Can I go for R1, sir? If I go in for R1, this 1 comes once again here. Becomes some other number. 1 comes here. So, making of this 0 becomes useless. So only we are not moving R1, we are moving to R2 because 0 plus 0 is once again 0, no problem. So, this is minus 3, this is plus 3. Can we become 0 easily? There is no change in R1, R2, there is change only in R3. So, you after equal to, you should put similar. This symbol only similar. There is change only on R3. So, write R1, R2 as it is. 1, 1, 1, 3. 0, minus 3, 1, minus 2. Right? Right? R3 tends to, this is minus 3 plus 3. Minus 3 plus 3, 0. Minus 3 plus 3, 0. R3 tends to R3 plus R2. I need to add minus 0 plus 0. See, we got 0. Minus 3 plus 3, 0. 1 minus 1, 0. 2 minus 2, 0. So, 0 rows, fully 0 rows, 1. Number of non-zero rows, okay, not number, non-zero rows. How many non-zero rows? 1, 2. Therefore, row of A is equal to 2. That's all. 0 row is only 1. Non-zero row. That's all. You can stop your answer itself. See how easy the sum is. We're going to do the sum. It will be very, very easy only. The sum is very, very simple format. See, this one 0, this one 0. Nothing but this contains 2 zeros. This contains 1 0. That's all. 2 zeros, 1 zeros. Over. This is some very easy sum. We'll move to second subdivision. Second subdivision here. First name the matrix. Let A is equal to 1, 2, minus 1, 3, minus 1, 2, 1, minus 2, 3, 1, minus 1 and 1. 1 minus 1 and 1. If you are going to check, this is not 3 cross 3, this is somewhat, it is not containing 3 rows, it contains 4 rows. So the problem what I want to do, this one I need to make, this one is first step is no problem. Listen, this one, this 3 elements should be 0. This one 0, this one 0, this one 0. Next I need to convert, these 2 elements should be 0. finally this one should be 0. You can just like this 3 should be 0, next to 2 zeros. In the previous sum, we are going to say first 2 0, next one 0, 2 zeros and 1 zeros. In this sum, these 3 should be 0, next to 2 0, and next 1 0. I want to check this one. This one is 0, 0, 0, 0, 0 and 0. So if these 3 should be 0, I need to get help of R1. This 2 should be 0, I need to get help of R2. This one should be 0, I need to get help of R3. That is R1, R2, R3, step by step. So first we will do similar step. So there is only change in R2, R3, R4. There is no change in R1. Write R1 as it is 1, 2, minus 1. There is change in R2. There is change in R3. There is change in R4. R2, R3, R4. There is a change. So this is 3. What this one should be minus 3. So multiply R1 with minus 3. Therefore R2 minus 3 R1. I will put here. Okay, first write R2. What is R2? 3 minus 1 2. Multiply with R1 into minus 3. 1 into minus 3 minus 3. 2 into minus 3 minus 6. Minus into minus plus 1 into 3 is 3. Is 0. This become minus 7. This become 5. 0 minus 7 and 5. Next, this is 1 1. So easily you can say R3 minus R1. 1 minus 1 0. Minus 2 minus R1 left. Minus 2 minus 2 minus 4. Minus 3 minus into minus plus 3 plus 1 4. 3 plus 1 4. Next we move R4. R4 also, this also 1 1. R4 minus R1. 1 minus 1 0. Minus 1, this is minus 2. So it becomes minus 1 minus 2 becomes minus 3. 1, this becomes plus 1. Because minus into minus plus. 1 plus 1 2. So next, what is the next? We are going to see this one is divisible by 4. This is R3. So there is no change in R1, R2 and R4. There is change only on R3 because this is divisible by 4. No. So 1 2 minus 1 0 minus 7 5 0 minus 3 2. R3 tends to R3 divided by 4. R3 divided by 4. 0 minus 4 by 4. Minus 4 by 4 is minus 1. 4 by 4 is plus 1. So see, these 3 zeros are next. This one should be 0 with the help of R2. With the help of R2. So there is no change in R1 and R2. There is change only on R3 and 4. Right? R3 there is change. R4 right change. So write R1 R2 as it is. 1 2 minus 1 0 minus 7 5. There is change in R3 and R4. What is change? Now we check. This is minus 7. This is minus 1. Check it carefully. What this one should be? What R3 should be? R3 should be minus 7. R3 should be plus 7. Plus 7 minus 1 becomes 0. But it is minus 1. So this R3 should be multiplied with minus 7. So R3 tends to minus 7 R3 plus R2. We will check. R3 should be multiplied with minus 7. 0 into minus 7, 0. Minus into minus plus. 1 into 7 is 7. 1 into minus 7 is minus 7. Now write R2 as it is. 0 minus 7, 5. See? Plus R2, no. Plus 0 minus 1, 5. The answer is 0, 0, minus 2. 0, 0, minus 2. Now R4 tends to. R4. This is minus 3. This is minus 7. So no way. This one should be multiplied with 3. This one should be multiplied with 7. I need to interchange. Therefore, this should be 7. 7 R4 and 3 R2. Problem is 3 R. This is minus. So I am going to put this one as minus 7 R4 because if it is going to we will check. This is plus minus 7. R4 should be multiplied minus 7. 0 into minus 7 0. Minus into minus plus. 3 7s are 21. 3 into minus 7 minus 14. Sorry, 2 into minus 7 is minus 14. Next plus 3 into R2. 0 into 3 0. minus 7 into 3 minus 21, 5 into 3 15, 0 0 1. See, 0 0 0 0 0. Now this one I need to make 0 because of 4 rows. 4 rows I need to make the formula. I need to decrease some step. This one is 0. If this one should be 0, I need to get the help of R3. There is no change in R1 and R2 and R3. So write R1 R2 as it is. 1 2 1. Because I need to make this one as 0. So this one is 0. There is only change in R4. There is no change in R1 R2 and R3. So write R1 R2 as R3 as it is. 0 minus 7 5 0 0 minus 2. So R4 tends to. This is 1. This is minus 2. I need to multiply 2. 2 R4 plus R3. So R4 should be multiplied with 2. 0 into 2 0. 0 into 2 0. 1 into 2 2. R3 0 0 minus 2. Totally going to be 0. Now 0 rows. 0 rows is 1. Non-zero rows 1 2 3. Therefore row of A is equal to 3. We can stop the sum here itself. Solution. First name the matrix. A is equal to 3 minus 8 5 2 2 minus 5 1 4 minus 1 2 3 minus 2. First step, A1 can be 1 or minus 1, but there is no 1 or minus 1. So I am going to interchange. R1 moves to R3. This R1 moves to R3 and R3 moves to R1. So two sides arrow. So there is no change in R2. 2 minus 5 1 4 is R2 minus 1 2 3 minus 2 R1 came. 3 minus 8 5 2 R3 came. So next this one should be 0 with the help of R1. There is no change in R1. Minus 1 2 3 minus 2 R2 tends to R3 tends to. This is 2. This should be multiplied with 2. That's enough. R2 plus 2 R1. 3 you should multiply with 3. R3 plus 3 R1. So first write R2 as it is. What is R2 here? 2 minus 5 1 4 R2. 2 into R1. Minus 1 into 2 is minus 2. 2 into minus 2. Sorry. Minus 1 into 2 is minus 2. 2 2s are 4. 3 2s are 6. Minus 2 into 2 minus 4. 0 minus 1 7 and 0. 0 minus 1 7 and 0. R3, write R3. 3 minus 8 5 2. Multiply with 3 R1. Minus 1 into 3 is minus 3. 2 into 2 3s are 6. 3 3s are 9. Minus 2 into 3 minus 6. 0 minus 2 14. 2 minus 6 is minus 4. 0 minus 2 14 minus 4. Even though there is minus 1 is present, even if minus 1 is not present, we need to interchange and we need to bring. So we are going to see this R3 is divisible by 2. So there is no change R1 and R2. Write R1 and R2 as it is. Minus 1 2 3 minus 2 0 minus 1 7 0. R3 tends to R3 divide by 2. 0 by 2 0. Minus 2 by 2 minus 1. 14 by 2 7. Minus 4 by 2 minus 2. So see, next I am going to make this one as 0. This both are 0. Next this one is 0. This one is 0. There is no change in R1 R2. Minus 1 2 3 minus 2. 0 minus 1 0. There is no change 1 and R3. R3 tends to. This is minus 1. This is minus 1. Can't be 0. So this one should be plus 1. It should be plus 1. I need to multiply with minus. R3 tends to R3 minus R2. Write R3 as it is. 0 first write R3, sorry, 0 minus 1 7 minus 2, multiply R2 with minus 1, 0 into minus 0, minus into minus plus 1, 7 into minus minus 7, 0 into minus 0, 0 0 0 minus 2, 0 0 0 minus 2, 0 rows. There is no 0 rows, there is one element, so 0, no 0 row is present here, right? Number of 0 rows, number of non-zero rows, 3 are non-zero rows, so row of A is equal to 3. In previous step put number of, that's all. Within this we are finishing this exercise 1.2. Thank you.